All right, here we go. So solving applications is what we're working on today. Okay, and what we do when we solve applications is basically is just that. We're going to solve, okay, when we apply it to something. Now here's the truth. Okay, listen. Shh. Honestly, we always talk about, real world problems, and textbooks will give you a real world problem and this and that. But the truth is most of the time, they're not really real world problems. More or less, they're just problems with words on them. Okay? Now, but in honesty, to be fair, you've got to know these for the STAR test. But reality is that when we do math, for most average Americans, you're going to do math in some kind of scenario. Some kind of scenario. Like, for example, because everybody's like, oh, well, I don't ever do algebra. Is it working?
No.
Okay. Okay, when we do algebra, people are like, oh, I never do algebra. Okay? And the truth is that your parents do, and you really do. If you go to the store, because you're clothes shopping, and you go to the store and you say, oh, these are some pretty sweaters. So, they're 2 for $50. How much is one? Okay?
2 for...
So 2 for $50, and you get one of them. How much are you paying? 25. Amazingly, you just solved the equation 2x equals 50. Okay? 2 times how much equals $50. You did that without realizing that you did algebra. So that is an application type of problem. And you do that all the time. Your parents, my wife used to do this to me all the time. But now she's getting her college education. And so because she's getting her college education, she's learning math on her own. And so, but she used to call me all the time from the grocery store and say, okay, I can get 4 for $5, or I can get 3 for $3.50. Which is a better deal? And that's all algebra. That's what that is. We just don't call it that. And nobody sits there and says, let me bust out the equation. I'm going to write problems, okay? So, Carl weighs 115 pounds and needs to gain weight. He gains 2 pounds per week, okay? And the week is represented by the variable x. Write an equation that will help you determine how many weeks it will take to weigh y pounds. Okay? Because it's a good method. Okay, so Carl weighs 115 pounds. He needs to gain weight. Yes, ma'am. Okay, well, hang on one second. First of all, how do we want to write our equations? What form? Slope-intercept. Yeah, slope-intercept is generally the easiest way to write an equation. Now, let me show you this again, and I've showed you this before. But when we do these equations, what we end up with is not that.
Would it be?
Y equals mx plus b, right?
Yeah.
Now, let's talk about a couple things with that. What is y? What does y represent?
The pound to weight.
Okay, I'm just talking about overall, every time. Dependent variable, right? Okay, what is x? Independent variable. What is m? It's the slope, but nobody refers to it as slope. Nobody refers to it as slope in a real world scenario. You don't see somebody out in the store going, what's slope? What's the slope of this situation with the sweaters? What's slope? Okay? Nobody refers to it as slope. What do we refer to it as? A rate. It's a rate. More specifically, what you probably learned in middle school somewhere, it's a unit rate. Per unit. How much is it? When I say 2 sweaters for $50, you say that each sweater is $25. So it's $25 per sweater. So the unit rate is for every unit, every one sweater, it's $25. So that's what you're really finding out. So it's your rate. Okay, so that's exactly what it is, your rate. Okay? And then finally, what is B?
Your y-intercept.
Okay, it's your y-intercept. It's your initial value is a better term because that makes more sense. That makes more sense in the real world. Okay? The other term that we used the other day was what? Starts with a C. Constant.
Or naked.
Okay? Or naked number, which outside of this class, not many people know what a naked number is. But yes, a constant. So if I know what each one of these things represents, when I take this application problem, what I can do is I can break the problem down and start putting stuff in there. Okay? Start plugging in the stuff. So let's just start from the beginning. Carl weighs 115 pounds. Where does 115 pounds fit in this scenario? Okay, it's the initial value. Why is that the initial value? Because he already weighs 115 pounds, and this whole scenario deals with what?
Adding on weight to that.
Yeah, adding on weight. He wants to gain weight, right? That's the whole thing. So he weighs 115 pounds, so he wants to gain weight. So that's the initial value. That's where we're starting. Now, he gains 2 pounds per week. Okay? What is that? That's the slope or the rate. Why is that the slope or the rate? Because it's constantly going up. That's a great way to rationalize. But what is an indicator that tells me that that is a rate? Per. The fact that it says per indicates it's a rate. Per means multiply. And notice how Reagan just said it's 2x. What are we doing with 2x? Multiplying. Okay? And here's the great thing I love about my class and students in general. Is students always, every time I have a student in pass, and I'll say, okay, what's happening with 2 and x? It's 2x. Well, yeah, it's 2x, but what does that mean? It means 2 and then x. Yes, but what does that mean? That means what? Yeah. Yeah, she went into major detail. But yeah, it's 2 times the number, right? 2 times any number x, or its multiplication is the key. The reason that's important is because the word per means multiplication. And so anytime you see that, that's going to be some kind of rate. Okay, so now we have now we have equals 2x plus 15. We're going to keep going on. Is x the right thing to put there? Okay, so do I want to take x out or leave it there? Leave it there. Why do we want to leave it there? What does x represent in the scenario? The weeks, right? Okay. Is weeks independent or dependent?
Independent.
Independent. Why?
Because it's.
There's 3 answers. Okay, why?
Because the pound. Oh
Time, and time is almost always independent. It is absolutely always moving, generally. Okay, so time is almost always independent. So that, we're talking like 98% of the time it's independent, or 99% of the time it's independent. Okay, so that's one reason I know it's independent. How else do I know it's independent?
Because it's increasing.
Okay, what did I tell you about independent, dependent? It doesn't depend on anything, okay. But what I tell you about independent, they always happen first. Doesn't the weeks have to happen before you can gain weight? Yeah, the time isn't waiting going, please gain 2 pounds so we can have another week. Please gain 2 pounds so we can have another week. Okay, we got 2 pounds, we got a new week. It doesn't work like that, right? Instead it's, hey, I've got the week's going to go by, and after this week I hope I've gained 2 pounds, right? Okay, now, so that's another way to determine that's independent. And then the third way to determine it's independent is the fact that what's always happening between the slope and the independent variable? We just talked about it for a long time. They're always multiplying, right? What does this say? 2 pounds per week. 2 times week, right? Okay, so that's the other way to determine that that is the right place to put that x. And then last but not least, by process of elimination, we know y is just y, right? Goes right there. No change. We know that by process of elimination, and we also know that pounds is what?
Why?
Pounds is what? Dependent because why? What does it depend on? The weeks. Hey, each week I need to gain more pounds. Each week I need to gain more pounds. Weeks have to go by, and the pounds should be adding up, right? So there's our equation. Now, our equation. That's pretty good. I want to market that. That's our equation, okay? So, here's the deal. Now we've created this equation, and we did all of that work, which again becomes quicker, okay? But we did that work so that now we can go ahead and we can solve for this number 2. Because number 2 says, how many weeks will it take him to weigh 141 pounds? Where does that go? Okay, y. How do I know it goes into the y value? Because y is the pounds. It tells me that in the problem. And it's dependent. And what do I know x is already? Weeks. This says pounds. Pounds, they go together. Okay, make sure you do that. A lot of students always just throw stuff into X because it's easier, for one. Throwing stuff into X is easier. But you got to make sure you match the variables with what they go with, okay? So we know that we put it in for Y because right there it says Y is pounds. Okay? So now I'm going to plug it in and solve. So what's my equation going to look like now?
Did you just find the difference between,
I'm sorry?
what I did is I just found the difference between 141 and 115 and just divided that by 2.
Yeah, what you did, we're going to do the same thing. You just make sure you go through the process. Now here's the deal. I just told you a second ago I'm not overly concerned with some of the exact things when it comes to math, except that when we do organize our work, that's important because when we move to the next level, you know, like going to geometry and then going into algebra 2, which everybody will have to take, you need to make sure you're organized. Okay, so now, Nathan just told me how he solved it, which is exactly the same. We're going to solve it. We're going to probably be a little more organized. Okay, so what do I do first?
Put the line down.
Yeah, subtract 115 from both sides.
Put the line.
Oh, draw the river.
You get what?
26.
So I end up with 26 equals 2x. Now what?
Divide both sides by 2.
I'm going to get rid of this so I have a little, whoop, not that. I'm going to, because you've done this for weeks, I'm going to get rid of this so I have more room. Okay. So now I have 26 equals 2x. Kirsten, go ahead and tell me what was I doing?
Divide both sides by 2.
Divide both sides by 2.
13 equals X.
So 13 equals x. So what do we just figure out for Carl?
How many weeks?
First, he spells his name wrong also because he needs a C. Okay.
Yeah, he does.
Anyhow, but we also just figured out that it'll take him 13 weeks to weigh 141 pounds.
Not according
Who
to
wants to gain
Peter
weight?
says
Exactly.
That's what I was thinking.
That is true. Okay, do what?
Who wants to gain?
Who wants? That's a good question. Fair enough. Wrestlers want to gain weight. Who else?
But muscle weight. He just wants to gain weight.
Yeah, but you know who else?
I'm losing weight.
Okay. Sumo wrestlers might want to gain weight. Anybody else?
Bro, they started.
Actors. Hey, that's a great one. Actors may want to gain weight for a certain role. Okay. How about? Huh? People who are underweight, right? People who are underweight might want to weight. Hey, listen. What if this guy? Because it doesn't tell you. What if this guy is 6 feet tall, 115 pounds? He might. Yeah, he'll be ridiculously skinny, unhealthy. Okay.
His arms are like that, skinny.
All right, here we go. Let's look at our next example about Miranda. Okay? I don't think so.
Hey, Coach Melms, do you
Oh,
know
I
who
know.
Mr. Powell
We only
was
have
from
4
last year?
minutes.
No,
You know who Mr. Powell is?
no.
He was one of the assistant directors last year, and he was about. He was like that big around.
he was unhealthy.
Yeah, he was like six.
I
He
saw
was like
this lady.
6'10", 6'11".
I saw this lady at the mall, and she was running through the
Okay.
the halls, and she was like this skinny.
Great. Okay, we're going to do this one quicker without all the breakdown. Okay, here we go. Miranda, okay, Miranda borrowed money from her parents for One Direction tickets. Yay! She is paying back her parents $9 each month. Okay? So each month is represented by the variable x. She borrowed $108 from her parents. Write an equation that will help you determine how much money y she still owes her parents. Okay, so what equation are we going to be in?
MX plus B.
Okay, y equals mx plus b.
We have like 3 minutes.
Okay, I got it. Thank you. Okay, now, let's break it down. Does the first sentence tell us anything?
No.
Just that she has a poor taste in music. That's it. Okay? She is paying back her parents $9 each month. What does that mean?
9x.
9x. Okay, because we're multiplying. What tells me we're multiplying? Each. Okay, where does 9x fit into this?
Right in the X.
mx, right? So now I have, okay? Now here's the deal. He's saying negative 9x. Why?
Because she's losing money.
Because, well, she's losing money. That's a way to look at it. How else?
Because she's paying back.
She's paying off a debt, right? Because what we're going to find out is it's negative 9x. Now, here's the deal. Let's start with 9x, because that's what y'all said, right? Let's start with that for just a second. So 9x. Then we keep going on. She borrowed $108.
Minus 108.
Okay, you could do minus 108, right? Let's see if this all works out. She borrowed. Because she borrowed, it's negative 108. So let's see if this works out. And then we want to see how much money, we want to write an equation that'll determine how much money Y she still owes her, okay? So, there's our equation. Based on what you said initially, there's our equation, right? Now, it says, how many weeks will it take Miranda to pay her parents back? So, what is weeks? No. We said positive. He said negative. So we're going to keep our equation the way it is. Okay? So, she wants to pay her parents back. What does that mean? She wants a balance of what? Okay, just change this to weeks. I mean months, sorry. How am I going to break this down? What do I want to plug in? What does that mean? She wants to pay her parents back. She wants to have a balance of 0. Where does that go? The Y value, right? So Y is now 0. So 0 equals 9x minus 108. What do I do now? Yeah, I need to add 108 to both sides. Now what? Divide by 9. What's 108 divided by 9? Okay, why does that work?
The bell just rang.
Okay, we'll talk more about that later. Now here,
Oh, we have homework.
yes, on your way out,
Run.
on your way out, grab your homework. Okay, it is due tomorrow.
You walked out of the way.
He ain't gonna do it.
He never does it. But I can't really talk.